or examples of being able to compute the curl of a vector field. So we have this f of x, y, z is equal to x e to the y I plus y e to the z k. Every time we want to find the curl, we start by setting up a determinant. So curl of f is going to be equal to our determinant. Remember the first row, I, j, k, all the time. Second row, d dx, d dy, d dz. And then the last row is always going to be the vector function. Now in this one we're going to be careful because there's no k components. So that's x e to the y, 0, and then y e to the z. And then we're just going to go through and compute. Okay. Now remember the trick that we saw in the last video. Cover up the first column, cross the second ones. Okay, so or the second and third column. So our curl is going to be equal to d dy times y e to the z minus d dz of 0, and then we have our I. Second term is always negative, so we're going to have boxing out the j column. We have d dx y e to the z minus d dz x e to the y, and we're going to squeeze a j in there again. Right. And then finally we have our k component, so we're going to cross the first two columns, so that's d dx of 0 minus d dy of x e to the y of k. Right. We compute, and it shouldn't be too difficult for us at this point. Partial with respect to y of y e to the z is e to the z, and then 0, so we have e to the zi. Partial with respect to x of y e to the z is 0. Partial with respect to z of x e to the y is 0. So there's no j component. So that's good. And then derivative of 0 is 0. Derivative of negative x e to the y with respect to y is going to be negative x e to the y. And then we have a k in here. Again, that's our curl. Shows us the rate of rotation at any point x, y, z of the original vector field. One last example. So let's consider a vector v, this time a fairly easy vector field, x plus 2y plus 4zi, 2ax by minus zj, and then 4x minus y plus 2zk, where a and b are just real numbers. First, is the vector field conservative? Why or why not? And then we want to find all values for where a and b for where v is irrotational. So let's start by finding the curl. The curl of v, just like we've done 2 other times, ijk, d dx, d dy, d dz, right? And then finally, we're just going to put the function in. So x plus 2y plus 4z. And then I'm just going to stick this right here. We have our 2a plus by minus z. And then we have 4x minus y plus 2z. All right, that's our determinant. Now let's go through really quickly and find the curl this time because we've already done it several times. So we're going to cover up I. So derivative of, so we're multiplying down and then multiplying up, and that's going to give us our I. So that's going to be negative 1. And then if we multiply up, that's going to be another negative 1. So negative 1 minus a negative 1 of I. For j, so we're going to cross these out now. And we're going to go down and up. So derivative with respect to x is 4 of 4x minus y plus 2z. Derivative with respect to z, so that's going to be minus 4. All right, so that's good. So now the first 2 terms are going to go away. And then let's see if everything goes away. All right, so we're going to cross down and up. Okay, so for k, we're going to take the derivative with respect to x. So that's going to be, in this case, I think I might have made a copy here. So that's 4x by. Okay, so it's 4ax. There we go. Or 2ax, excuse me. All right, so derivative with respect to x is 2a. And then going up, derivative with respect to y is going to be just 2. All right, and there should be a minus in there, excuse me. All right, or in other words, our curl is just going to be 2a minus 2 of k. Now clearly, this is not equal to the 0 vector. If it were equal to the 0 vector, then it would be conservative. All right, so a, since we're saying that the curl of v is not equal to the 0 vector, then what we can say is that it is not conservative. All right. So that's easy to answer for letter A. For letter B, remember it asks us find all the values for where v is irrotational. Well, irrotational means that there are points x, y, z to where the vector, the curl of the vector is going to be 0. So what we're going to do is we're going to say 2a minus 2 has to be equal to 0. Okay, so all we're doing is we're just setting each of the coefficients of I, j, and k equal to 0. Now clearly that tells us that a is going to be equal to 1. It also tells us that b can be any real number, okay? Or if you want to do it in one letter, you could just say b is an element of the real numbers. Right? So to be able to determine where a vector field is irrotational, just set each of the components of I, j, and k equal to 0 and solve. All right? In this case, we're going to say it is irrotational when a is equal to 1, and for all real numbers, or we could just say for all b as an element of the real numbers. All right, you could just write that out if you wanted to. So if you just say for all real numbers b, however you want to do it. All right, so hopefully this helps grasp the idea of what curl is, how to compute curl, and then look at some of the applications of curl with respect to irrotational as well as conservation. So the next video series, we're going to take a look at the idea of divergence, which is another property of our vector fields.